Yes, good morning students. Then in the previous class we already discussed few geometrical isomerism. So what is the geometrical isomerism? That geometrical isomerism nothing but cis trans isomerism. So which one is the form cis, which one is the form trans, and how to calculate the geometrical isomerism in polyene. That polyene the double bond is even, its double bond is odd, we already discussed. Then physical properties of that geometrical isomerism is also already discussed. Then to be continue of that topic, that is geometrical isomerism in nitrogen compound. Then today it is just a few minutes topic. Afterwards we discuss conformational isomerism. So geometrical isomerism in nitrogen compound. So this geometrical isomerism in nitrogen compound means, for example, here C6H5, then C double bond NOH, NOH and H. So this H and OH, which are both are in same inside, are called syn. This is called syn benzol dioxide, syn benzol dioxide, benzol dioxide. So which means these H and OH are in same inside. So what is anti? This anti nothing but like this. See this one, C6H5, C, this is C, C6H5, C, H, double bond, N, OH. These are called anti-benzol dioxide, benzol dioxide. So that means OH and HR which are anti to each other. One more example for this one. Next one, CH3, C double bond N, this side C2H5, this side OH. So its name is ethyl methyl, ethyl. So according to this, C nothing but one carbon methyl, two carbon nothing but ethyl. So ethyl, its name is ethyl methyl, ethyl methyl ketoxime, ethyl methyl ketoxime. So in this one, this means syn, this is syn, syn ethyl methyl ketoxime. Here C2H5, C2H5 and OH which are syn to each other. Then what happened in the next one, anti means CH3, C double bond N, this side C2H5, this side OH. This is anti, anti ethyl, anti ethyl methyl, anti ethyl methyl ketoxime, ketoxime. So this is geometrical isomerism containing few compound. Next one, the same time this geometrical isomerism containing cycloalkane, cycloalkane. So what is cycloalkane? The best example of cycloalkane is cyclopropane. So this is this one, this is cyclopropane. Now this is CH3 and this is H. Now coming to this side, CH3H, its name is cis 1,2 dimethyl cyclopropane, cis 1,2 dimethyl. This is cis 1,2 dimethyl, cis 1 comma 2 dimethyl cyclopropane. Cyclopropane. Now let us another example of this one. See this one. This is 6 membered ring, and what up yes. So what is now 6 membered ring? We can, so this is, it is an 6 membered ring. This is OH, this is also OH, this is hydrogen, this is hydrogen, this is 1 carbon 2 carbon, this is cis 1 comma 2, cis 1 comma 2 cyclohexane diol, cyclohexene diol. So this is, now for example, one more example of this. See, this is in 5 membered ring. So like this is trans to each other. That means this is OH, this side OH, this is trans 1 comma 2 cyclopentene diol. So this is one more structure. So for example, like pentane, like that. So what is pentane? This is pentane. This is OH, H. This is OH, H. This name is trans 1 comma 2, trans 1 comma 2 cyclopentane diol, pentene diol. So this is what happened? Geometrical isomerism in nitrogen compound. The next one, geometrical enantiomerism. Next, a small topic, that is geometrical enantiomerism. Geometrical enantiomerism. Enantiomerism. This geometrical isomerism nothing but, for example, few compound is formed like this, few compound is formed like this, C double bond C, this side H, this side CH3, and this side like this compound is formed, simply CH2 COH, CH2 COH, and one more carbon CH3H. This is CH3 and H, and this side CH3. So what happened? This compound is formed geometrical as well as optical. The above example is formed geometrical as well as optical, geometrical as well as optical isomerism. So that are called geometrical enantiomerism, enantiomers. So we already discussed which one is the optical isomerism there, which one is the optical isomerism, that are called what happened? Geometrical as well as enantiomer form. Now one more example for that geometrical and optical isomer. So this one also form geometrical and optical isomerism. This is CH3, CH, Cl, CH, Br, CH, Br, and other to be continue of that, then CH, double bond, CH2, CH3. So this type of example is also formed geometrical as well as optical isomerism. So one more example for that. So geometrical as well as optical isomerism. So, like this is the example of above. This one CH3 CHCl CHBr CH11 CH single one CH3. This example is from geometrical as well as optical isomerism. Geometrical as well as optical, that's way it is called geometrical enantiomers, geometrical as well as enantiomers. So, what is geometrical? Nothing but it is from cis strands and optical isomerism. So, that's why this is geometrical isomerism containing nitrogen compound. So, here carbon and nitrogen are in same inside are called syn addition, syn benzyl dioxide. And what happen? This is cis 1,2 dimethyl cyclopropane. This is cis 1,2 cyclohexane diol, this is cyclohexane diol, this is cyclohexane diol, this is cyclohexane diol, this is trans 1,2 cyclopentane diol. This geometrical enantiomer nothing but this is from geometrical as well as optical. It is also from geometrical as well as optical. That's why these are called geometrical enantiomerism. That's why that structure are called geometrical enantiomerism. After that, conformational isomerism. This conformational isomerism, now let us the best example of conformational isomerism is butane. The best example of conformational isomerism is butane. So, in this conformational isomerism, these butane contain two type. This conformation of butane contain 6 type of conformations are formed. That 6 type of conformations are called Newman projection formulas. In that Newman projection formulas, so these are 2 type, that is one Stargate conformation and second one is eclipsed conformation. So, what is conformation of butane? Now, let us we discuss. Next one is conformational isomerism. Next topic is goes to conformational isomerism. Now, what is the meaning of this conformational isomerism? This conformational isomerism. Conformational isomerism. So, now the best example of conformational isomerism is N-butane. The best example of conformational isomerism is N-butane. So, the best example, now today we discuss this best example is butane. The best example is butane. So, butane formula is like this: CH3, CH2, CH2, CH3. This is butane. Now, this is first carbon, this is second carbon. Okay. Now, these conformations of butane, this is first, this is Newman projection formula. In this one, here what happened? CH3, this is H, this is H. That means, what is the meaning of this one? This carbon contain one CH3 group. this carbon contain one CH3 and here two hydrogens. The remaining, this carbon contain two hydrogens, one CH3 and remaining two are hydrogen It's rotate 60 degrees centigrade. It's rotate 60 degrees to get like this compound is formed. To get like this, what happen? So this is the form which are closest to each other. This is CH3, this is H, this is H. Now what in this one, this CH3 comes to this side, and this hydrogen is this side, this hydrogen is this side. This is second one. Now if again rotate 60 degrees, it is again rotate 60 degrees to get what happen, like this compound is formed. So this is CH3, H. Other carbons are, this CH3 comes to this side, this hydrogen is this side, this is this side. Okay. Now this is one, this is second structure, this is third structure. What happened in the fourth structure? I am using, this is second structure. Now fourth structure is, this is the fourth one. Now again 60 degrees. This is again 60 degrees. So now like this is formed. So here what happened? CH3, here H, this side H. Now, so these which are close to each other, this is CH3, this is hydrogen, this side hydrogen. This is fourth structure. Now coming to fifth, 60 degrees to get like this structure is formed. So this is CH3, the first carbon is no change, hydrogen. Other are this coming to this side CH3, this side hydrogen, this side also hydrogen. This is fifth one. Now what? Now it is again rotate 60 degrees to get like this Newman projection formula, like this is formed, that is CH3, H. Now here what happened, this CH3 comes to this side and this is hydrogen, this is hydrogen. This is sixth structure. So what happened, in this butane there are 6 structures are formed, 1, 2, 3, 4, 5, 6. So these butanes are basically 2 type of structure is formed, that is one Stargate confirmation. One is Stargate confirmation and second one is eclipsed, and second one is eclipsed confirmations. In this one, Stargate confirmations are 1, 3, 5. These 1, 3, 5 are called Stargate confirmation, and other 2, 4, 6 are eclipsed confirmation. 1, 3, 5 are Stargate confirmation, and in this Stargate confirmation 1, 3, 5 are Stargate confirmations. So these Stargate confirmations, in this one, this is 1, 3, 5 are Stargate confirmation. So 1, 3, 5. So in this Stargate confirmation, these are, in this one, third structure is called anti. Third structure is called anti, and 1 and 5. 1 and 5. These 1 and 5 are called Gachi. 1 and 5 are called Gachi confirmations. 1 and 5 are called Gachi confirmation. Gachi confirmations. So, what is the meaning of this Gauchy? Here in this one, anti-conformation is stable. Anti-conformation is stable conformations. Anti-conformation is stable conformation than Gauchy conformation. Anti-conformation is stable conformation than Gauchy conformation. Now, this anti-conformation is stable conformation than Gauchy conformation. So, this next one 2, 4, 6. These 2, 4, 6 are called eclipsed conformations. Now, in this eclipsed conformation, this 2 and 4 are called eclipsed. 2 and 4 are called eclipsed conformation, and 6th conformation are called fully eclipsed. Fully eclipsed, and 6th conformations are called fully eclipsed. Now, in this one, this fully eclipsed conformation is least stable. This fully eclipsed conformation is, it is an least stable conformation. Least stable. It is least stable conformation. So, that's why in the Stargate, in this one 1, 3, 5 are called Stargate conformations. 2, 4, 6 are called eclipsed conformation. These Stargate conformations are anti-conformations and Gauchy conformation. That means that the third structure is called anti-conformation. That means the two CH3 groups are which are opposite to each other, and other 1 and 5 are called Gauchy conformation. This third structure is anti-conformations is very stable, and other 2, 4, 6, other 2, 4, 6 are called eclipsed conformation. In this eclipsed conformation, the 6th structures are, the 2, 4 structures are called eclipsed, and 6th structures are called fully eclipsed. Now, its order is very important. Now, its order is like this. This is 3 is greater than 1 and 5. 1 and 5 is greater than 2, 4 is greater than 6. So, these 3 are called, now simply, now I am writing from this side, anti. Anti is greater than Gauchy. Anti is greater than Gauchy, and Gauchy is greater than eclipsed. Eclipsed is greater than fully eclipsed. Now, in this one, so here this anti and Gauchy, its bond energy is nearly it's not equal to 0.9. Its bond energy is not equal to 0. That means the both the bond angles cannot be equal to the both the bond angles cannot be equal to 0.9. So, this is what is conformation of butane. So, what is the conformation of butane? Now, in this conformation of butane, these butane conformations are, now butane conformations are 6 types. That is, one is Stargate conformation and eclipsed conformation. Now, in this one, Stargate conformations are 1, 3, 5 are Stargate conformation. Among this one, third structures are called anti, and 1 and 5 are called Gauchy. The third structure is called stable conformations, and in this one 2, 4, 6 are called eclipsed conformation. This 6th structure belongs to fully eclipsed. This is least stable. That means the two bulky groups are which are closest to each other. The two bulky groups are which are closest to each other. That's why its bond angle is 0. Now, this anti-bond angle is 180 degrees. That means which are opposite to each other. So, its order is anti-conformation, Gauchy, eclipsed, fully eclipsed. For example, in case 2 hydrogen is there, it is now what is for example like this here. Now, this is very important. So, what is that? In case the 2 OH, now I am using for different pen. See what we observed, for example, this is 1, here OH, this side H, this side H. Okay. Now, this side OH, this side H, this side H. But what we observed, this is anti-conformation. Now, in case the 2 OH are up, this is more stable, but here the structure is least stable. The structure is least stable. So, that structure is least stable means no intramolecular hydrogen bonding, no intermolecular hydrogen bonding, no intermolecular hydrogen bonding, no intramolecular hydrogen bonding there, that is why that is least stable. So, what is the more stable structure? So, like this, for example, this is the more stable, this is I am writing OH, this is H, this is H, and coming to this side, and this side OH, this side H, this side H. This is more stable. This structure is belongs to more stable. That more stable means intermolecular interaction between oxygen and hydrogen. Intermolecular attraction between oxygen and hydrogen. For example, one more example for this. So, among this one, which one is the stable and which one is not stable? See, one more example. So, for example, OH and Cl. For example, this is one of the example. This is this side OH, this side H, this side H. Okay. Now, this side chlorine, this side chlorine, this side hydrogen, this side hydrogen. Now, here this is more stable, this is more stable, this is more stable, that means dipole this is least stable, this is least stable, this is least stable, least stable. What is the more stable structure? This is the more stable. This is here chlorine, this side hydrogen, this side OH, this side hydrogen, this side hydrogen, this side hydrogen. This is more stable. This is more stable mean dipole interaction. This is more stable mean dipole interaction. Dipole interaction between hydrogen and oxygen. So, this is conformational structures of butane, conformational isomerism. What is the conformational isomerism? This conformational isomerism, the best example is butane. These butane contain 6 type of Newman projection formulas. In that Newman projection formulas, these are 2 type of Newman projection formulas, that is one Stargate and second one is eclipsed. That Stargate means 1, 3, 5 are Stargate, 2, 4, 6 are eclipsed. In this Stargate conformation, these third structure are called anti-conformations. 1, 3, 5 are Gachi conformation. That third structure, that anti-conformation is very stable, more stable than Gachi, the more stable than Gachi. So, that is why the way that third structure is belongs to stable, the two alkyl groups, the 2 methyl groups are which are opposite to each other. Other are 2, 4, 6 are called eclipsed conformation. Among this one, a sixth structure are called fully eclipsed. This sixth structure is called fully eclipsed. That is least, it is least stable. It is least stable. That's why this structure is called fully eclipsed. It is least stable, LS, least stable. So, then compared to this 2 and 4, that means its bond angle is 0 degrees. That means the two bulky groups which are closest to each other, that's why its bond angle is 0 degrees. Now, its bond angle is anti-bond angle is 180 degrees. its order is anti, Gauche, eclipsed, fully eclipsed. The next one, the 2OH, the 2OH, the 2OH are in same inside, the 2OH are in same, it is least stable, that means no intramolecular hydrogen bonding is there. Now this is least stable, this is more stable, this is more stable, that means intramolecular hydrogen bond between oxygen and hydrogen. What is this structure is least stable, this structure is more stable, that means dipole, there is no dipole interaction between them. Here dipole interaction between hydrogen and chlorine. So this is what happened, conformational isomerism. After this conformational isomerism, stereochemistry is there, that stereochemistry of addition reactions. So that stereochemistry of addition reactions to be continue on next class. Okay, thank you very much.